Hello, today we'll be doing number 42 from 10.2, which is suppose that S equals the infinite sum of A sub n is an infinite series with partial sum Sn equals 5 minus 2 over n squared. Part A is what are the values of the sum from 1 to 10 of A sub n and the sum from 5 to 16 of A sub n. So this is actually pretty simple once you realize that the sum from 1 to 10 is S sub 10. So you can just substitute n equals 10 in this case. So this is your rule. You just plug in 10. 5 minus 2 over 10 squared is 5 minus 2 over 100, or 4.98. So for part B, we're going to have to do some more thinking. We still don't know what individual values of A sub n are yet, but we can realize that the sum from 5 to 16, n equals 5 to n equals 16, is just the sum from 1 to 16 minus the sum from 1 to 5. So that's going to be S16 minus S5, which is 5 minus 2 over 16 squared minus 5 plus just distributive property 2 over 25. You have 2 over 25 minus 2 over 256. And that gets you 231 over 3200. That's not part B, that's the second part of part A. Okay. Now, part B. What is the value of A3? So that's the third element of A. And if you think about S3, that's going to be A1 plus A2 plus A3. Right? And S2 is going to be A1 plus A2. So if you subtract them, you get A3, because everything else cancels out. And we just plug in S3 is going to be 5 minus 2 over 3 squared minus 5 plus 2 over 2 squared, or 2/4 minus 2/9, or 1/2 minus 2/9, or 5 over 18. Okay, so that is part B. Part C. Find a general formula for A sub n. Okay, so kind of like this example right here, we took S sub something and subtracted from it S sub something minus 1. So we can just actually go A sub n is equal to S sub n minus S sub n minus 1. Because remember, everything else would cancel out besides A sub n. And we know what S sub n is. It's 5 minus n squared, 5 minus 2 over n squared. And just once again, using the distributive property, 2 over n minus 1 squared. So the 5's cancel, and you're left with a sub n equals 2 over n minus 1 squared minus 2 over n squared. Okay. And part D is find the infinite sum of a sub n. So that's just going to be s sub n as n approaches infinity. So let's just plug n into the expression for s sub n. Sub n. Or you can also write it like this. The limit as n approaches infinity of s sub n. Which equals the limit as n approaches infinity of 5 minus 2n squared, 2 over n squared. And clearly so that's the limit as n approaches infinity of 5 minus 2 over n squared. And the limit as n approaches infinity of 2 over n squared is very clearly 0. And that just leaves the limit as n approaches infinity of 5. And that is 5. Okay, hope this helped.